everybody, welcome. My name is Grant Sadowski, CEO and founder of Becoming 3D. So I want to thank everybody for coming tonight. Had a great turnout. In fact, we kind of oversold. I think we had about 50 spots and ended up getting 50 or 60 voicemails on our phone this week on top of who we had already invited. So just glad you all could make it. So we have a really great event tonight. We have two speakers that have combined about 60 years in the industry. We have Dave Sepanik with us tonight. He's really an authority in this space, and he did a great presentation for us. We have Charlie Koch, who's 20 years doing rapid prototyping, 3D, done everything in that space for the last 20 years, and has a lot of stuff he's going to show us and kind of talk us through. So I'll let Dave take it over, and thanks again for showing up.
Thank you very much, everybody, for your time and attention. My name is David Sepanik. I'm the Director of Engineering at CAM Specialties in Palm Beach, Florida. And I'm here to talk about something that most people would not consider to be rocket science, but in all essence, it really is. 3D printing is a manufacturing revolution that's now upon us that can help you save time, cost, and help accelerate your designs into the marketplace like never before. And many of you know who CAM Specialties is, but for those who don't, I'd like to take a brief introduction to let you know what we do. We've been in business for 30 years here in South Florida in engineering, turbine engine design, manufacturing, procurement, sourcing. We do rapid prototyping, short-run production of state-of-the-art alloys. We do complete electrical, software, and a la carte manufacturing services. So we are trying to focus on companies that are looking to turn their fixed costs into a more variable approach with our engineering staff. We are a woman native-owned American company, and we manufacture and procure jet engine components for both hot and cold sections. We are more than just an engineering and rapid prototyping and raw material sourcing. Our customers include Pratt & Whitney, Boeing, Rolls-Royce, Lockheed Martin, Aerojet Rocketdyne, GE, and UTC Aerospace. And more than just military and aerospace, we focus on industrial and energy applications, medical devices, and consumer electronics. 3D printing of plastics, again, is a revolution. It is predominantly where 3D printing has been evolving from. We can get to the market faster with traditional plastics than injection molding. And one of my friends here runs an injection molding plant, and we're not here to completely disrupt your technology, but we're here to make some of the prototyping and advancements in design much easier and faster to sometimes hand it off to high-volume manufacturers. We reduce lead time, improve the design concept, traditionally smooth the prototype to manufacturing process, primarily in high-mix, low-volume, high-value propositions. So we're not here to try to make spoons or forks that you would traditionally make in China, but we're looking more for design concepts and products that we can and manufacture in the prototype process, in the manufacturing, without any of the traditional tooling and investments you would have to make to get to that level. And what are those processes? We all know SLA molds, soft tooling, aluminum tools, and then P10 steel in order to get those products to market. A lot of times, marketing gets it wrong, and we'd like to try to build a model where we manage inventory and turn your business more into an ETO, a build-to-order process. So your inventory costs are almost eliminated. We can reverse engineer a product. You have no designs. Use 3D imaging, 3D graphing to actually create a part without a drawing, and we can rapidly get that into production. We can can avoid all the secondary painting processes and actually produce the product in the Pantone colors that are commercially available. It's available now in thermoplastic ABS, which you see in your cell phones, vacuum cleaners, E-Denstone for dentures, E-Glass for clear optics, carbon reinforced plastics, and now even ceramics are coming out. 3D printing of plastics production advantages. Again, eliminates prototype tooling costs, avoids design charges. Most of you know every time you make a design change, it's a $2,500 flat fee. Those are a few $100s, if that. Minimal programming costs, avoid hard tooling costs, at least as we mentioned before. Reduces sheer number of parts. So instead of having an assembly that has 10, 15 parts, we can reduce that down to maybe 1 or 2. Reduces and eliminates assembly costs. So there again, we reduce the number of parts, complexity, and you eliminate labor costs. Significantly reduces raw material scrap, and that's key to the process. Another process that goes along with plastic is continuous liquid interface production, called CLIP. CLIP uses UV ultraviolet that triggers photopolymerization. I'm sure it's a little fancy language, but it allows oxygen to intimidate it. So it actually develops a part under light and continuously grows the object from a pool of resin. Amazing process. The advantages are polyjet printing is a great process for developing fully assembled complex assemblies and prototypes with detailed geometries using multiple material properties. The speed is amazing. With traditional plastic 3D printing, it could take hours, sometimes days. CLIP is 25 to 100 times faster. Ford Motor Company is developing a process and trying to really expand the footprint and actually start making automobile frames, parts, major structures out of the CLIP process. And that is brand new emerging technology for the automobile industry.
Sort of like the
Yes, like the Terminator. So, on the other flip side, plastics has been the emerging market for plastics. It's now gone into metal technology. And DMLS, direct metal laser sintering, is one of the most commercialized processes now. And it's becoming more commercialized and more mainstream now because it can actually be used from prototyping right into production. Again, significantly reduces lead time, makes parts in hours instead of weeks, eliminates the proto-tooling costs, less material waste. Major material waste when you're talking about sheet metal stampings, blanks, hogging parts off from bar stock. All that excess material is eliminated, which increases your margin and again, your position in the marketplace. Design changes can be made quickly without any costly tooling NREs. Again, every time Snyder wants to make a change, it's $2,500. Now, it's maybe $100. A couple of hours to make a change, and you're starting to make parts again in hours or days. It would take you weeks or months to make. We can use 3D scanners again, reverse engineer obsolete parts, same scenario, same kind of concept, right? Parts now are stronger than conventional machining because of the way that it's layered and the way that it's heat treated at the end, eliminating porosity, inclusions, and a lot of the challenges that you have. Making very hard, very highly stressed parts, primarily now being created in the jet engine industry and in the rocket industry. High-strength steel alloys include titanium, Inconel 625, 718, Ace 230, copper, and aluminum. Reduces the number of secondary operations. Again, no hipping processes typically. You even don't have to even machine some of the surfaces. They're actually producing the parts where they are just as good as machining, except when it comes down to severely tight tolerances with major surfaces. But now we're only talking about 1 or 2 processes versus a multitude of CNC processes that you have to take time, money, and speed to market. Significantly reduces the labor costs again for assembly because you can eliminate the number of parts and it can be completely assembled during that whole DMLS process. Sizes now are 16 by 16 by 16 inches, and it's growing rapidly. DMLS applications, again, turbine engine, hot and cold section components. Pratt & Whitney, GE, NASA, SpaceX are really running into this market, and they're looking for capacity, and that's what we offer our clients, a gateway into the capacity, and engineering expertise to guide you along the step of product development. Machine tool drills, right out of DMLS, ready to start cutting. Dental, jewelry, molds to make less injection molded parts. Prosthetics for humans and pets. Parts, the high strength alloys include, again, titaniums, Inconels, cobalt, chromium, stainless steel, maraging steel, copper, aluminum alloys. Another process, DMLS, is called EBAM, electronic beam additive manufacturing. This is a more a more wideband electron beam instead of a laser focus that you can find in DMLS. So this can reduce your costs and lead time by sometimes 80% in conventional CNC manufacturing techniques. It's the fastest, most cost-effective metal additive manufacturing process that's available in the market. EBAM produces high-quality, denser parts to powder metal approaches that you can find in DMLS. The widest range of commercially available metal 3D printing systems in terms of envelope and scalability. So the bigger the size, the bigger the platen, that's what this technology offers. Benefit from weight reduction, customization, complex geometries, and again, avoid those high-cost inventory for those type of parts, and you can turn it to more of a just-in-time approach, saving on inventory costs and inventory terms. The applications, aircraft parts, oil and gas equipment, nuclear components, refractory metal components, industrial pumps, power generation, semiconductor, manufacturing equipment, tooling, marine propulsion. You name it, anything that has metal in it. We have the materials available, commercially available, and the techniques to produce a part, again, in a high mix, low volume application, high value add. The pros and cons between EBAM and DMLS. EBAM uses, again, that electron beam to melt and diffuse the layers. So it's not as tight as DMLS would be with a more focused laser beam. I'll get into that. Lower focus, it uses much less material, faster cycle time, more applicable for the orthopedic implants, as Bill pointed out. Largest build envelope with 3D printed metal parts and fewer supports and anchors in order to create the part. On the other side, the DMLS uses lasers to melt and diffuse the layers, but it has one good side to that above EBAM, and that is that each layer can be done within layers of 30 microns, which can hold accuracy within 0.1 millimeters. So you can produce a part without typically any secondary machining in DMLS. EBAM, you probably are going to have to go in and do surface cuts and gating surfaces to make sure that your fits are tight and clear, as you would in a CNC machining process. It uses a bed of polymer resin that can be cured, and it's a commodity. SLA is a commodity, generated highly detailed artwork, non-functional prototypes, and can be used to make molds and investment casting applications. Again, 3D printing, set for revelation. Manufacturing, 3D printing of a pistol. We've made it already. Rolls-Royce is the largest 3D part of a major jet engine section, and they're even using parts in supersonic cars. The applications are endless. Additive manufacturing, again, has grown by 75% this year because it's becoming more commercialized. Developing business cases that are qualifying and certifying the parts for flight and orthopedic implants. A perfect fit for high value, low volume sectors. The cost of 3D printers are coming down. The size of the envelopes are growing rapidly. 3D parts can be made with much wider range of raw materials, again, in the most exotic, high-strength alloys you can imagine. There it is. Most everybody here is probably not a rocket scientist, an engineer, or an inventor. But let's just imagine you want to go back to the future, and everybody knows, Doc Brown and Marty McFly. What were they looking for? They were looking for a flux capacitor, and they couldn't find one. But just imagine now using 3D technology. We can turn around and make that part just like that. So 3D technology, the applications are endless. And CAM Specialties can help transition your company and help you choose the right approach for your business model. Again, we can take your 3D CAD file, we can take a part and reverse engineer it, we can design it from scratch, we can make it happen. We can make sure that your parts arrive on time and you're the fastest to market, and we'll get it done. Thank you very much.
Hi folks, my name is Charlie Koch. I'm from 3X Development, and I drove all the way from Tallahassee to see you. That's where actually I drove 2,000 miles in the last 10 days. So, I want to thank you all for being here today. My company, 3X Development, I've been in the 3D world, so to speak, down here in Florida for almost 20 years. When we used to tell people about 3D in the early days, it was sort of like, oh, I do stereolithography. You do what? And now you tell people you're in the 3D world, and they look at you like you're in the hottest business in America. You are so out there, it's insane. Watch any Mission Impossible, and they're always using 3D. It's something in there. Watch all the movies now, it's in every movie. So it's really interesting when you look at what all this means. And I'm going to explain what this photo's up here for you in a minute. But you have to take a little picture of history before we can come to where we are today. Because I like to do this analogy because you really have to understand what's going on. This is how we all started. Think about it. This was 3D. This was even 2D. It was flat, they made it flat. They beat it to a flat, it was flat. It was round, whatever they wanted. Used a rock. We got smart. We had a stick, we had a hammer. Okay? And think about it, for how long we used a hammer. And then some guy named Gutenberg came along. And he made a printer press. So we didn't have to try to figure out how to inscribe to scratch. And then bring it further, and you have a company, what they call Xerox. They made a printer so we could make paper. That would repeat itself. We'd have to do mimeograph to get high in high school. Sorry. And then along, I guess around the 70s, came 3D. Now I'm not talking 3D from a point of view of machinery. I'm talking 3D going beyond drafting. It wasn't no longer a drawing board with the XYZ. Notice how I got my logo if you guys don't know history. XYZ used to be on the bottom of every print. And I said, wow, if you take it, it can't be stolen because it's public. Pretty cheap way to get a logo. But you kept moving through that, and all of a sudden people were designing in 3D. Now, how many of you were engineers here at campus? So you remember the old days? Pencils? I don't. I come from the marketing world. See, my attitude is, we're all just making chocolate chip cookies. How do you make it, how do you bake it, and how do you get it on the shelf? What doesn't fit? Jet engines, military weapons, implants. Everything fits. We're all making the same thing, it just has a different panache. So when you look at what the technologies have brought along, all of a sudden, then comes 3D printing. Well, not really yet, we had stereolithography. That was the granddaddy. Back around mid-80s, the first 3D technologies were patented. A company called 3D Systems, DDD, up and down the stock market these days, but nonetheless. And they came out with this resin-based technology. It's basically Jello, ultraviolet sensitive resin. You put in your CAD data. Well, wait, wasn't that my Word document the week before? And the next thing you do, you have a part. Now, I'm going to tell you, when I first saw this business, I was like, it was like 2001: A Space Odyssey, right? Bang a bone, and out came the phone. I got it the day I saw it. I didn't know where it was going, but I said, oh, let's go for the ride. And then you look at what's happening, and all of a sudden we've escalated, accelerated further on. And now we have printers for everything. There's a printer that could be sold for your home. There's a printer that could be sold for your office. And there's the shift in technology. I visited a company this week up in the Panhandle in Santa Rosa Beach. Very hot spot, by the way. Great beaches. Here it is, Canon printer. And a different brand, but the maker runs. Next to it, it's sort of like the passing of the wind. You know, can we touch you and all of a sudden we're here? But this is really what we're all facing today. You're looking at a speed transition in manufacturing. Because I have another photo in here where they have 6 of these on one shelf, bigger units. This company makes simulators for the military, and their simulators are printed and sold to the government under ITAR and under ISO. They print what they need, they put the electronics inside, and poof. No disrespect, there's no tools. They're just making cookies. Oh, it's plastic. Well, actually, it's PLA. That's a new term for it. So you have to look at what all this, I'm sorry, PLA. Oh, I can never pronounce it. Buddy looks like, you know, the anacronyms in this industry are endless. Okay, DMLS. Okay, DMLM. That's the guys who don't want to call it DMLS. So you put a slash and you got it on your webpage, you get the hits and button. So you look at it from that perspective, and all of a sudden, what's happened here? Okay, where we've gone from hammer and chisel, rock, hammer and chisel, machine shop, and I will tell you with the DMLS technology that we're going to show you, if you own a machine shop, get into it now or get out of machining. Because when the platforms get big enough, look at it. Because the things you'll be able to make far exceed anything some people would ever imagine you could. And they are making parts now that can't be, quote, made traditionally in any way you can think about it in 7 to 10 days, where it would take 6 weeks to get a prototype that doesn't even look close. So that transition in speed that you're looking at and the applications it's going to have for you, just, it's a blink. Remember, Gene Roddenberry spent 2 years at MIT, picking brains before he ever made Star Trek. And if you look at how many products we've seen come and go, products that are extinct in our life, I'm glad LPs are making cut. But anyway, that are extinct because technology has pushed them aside. And we just found another way to do it. So, in talking about that, the way I looked at the whole business all these years, what always drove 3D was materials. Okay? When we first got into business, you had materials that were called stereolithography. They were basically, imagine Jello with cold. This is liquid with laser heat. And it cures it into a part before you ever make a tool. And there's all sorts of different materials and shapes and sizes. And what came along, first you had SLA, then you had FDM, which is like the machines we're talking about here. But this is a part that we put on the side of a thruster for an engine and test it in the water. Never make a tool. Traditionally, for those of you in manufacturing, it would either be hogged out or cast. But instead, in 4 days, I mounted it on a thing and went to work. 4 days. Not months, not years. The evolution of manufacturing is starting to happen. And then what happened next? There's a company out of Israel that made a machine called Polyjet. It could print 2 materials at the same time. It's like a dot matrix printer. Again, evolution, escalation, material choices. And we just recently got a part from a company out of Europe that's printing what's the equivalent of laser clear glass. No polishing, no anything. It comes right off the machine that clear. And this is 3D printing. And we haven't moved from the printer yet. We're still in materials. But the same thing you have to understand, for those of you who aren't in it, is it's all based on data. A lot of people traditionally talk about the drafting. Now it's all about the 3D. You know, we shared earlier that they can support you with engineering services. Anything you do, you can scan, reverse engineer, get a 3D solid, make a part. That is the key to the kingdom, your 3D solids. It's not that we can't use traditional old 2D to get someplace, but all these new technologies can't read a flat. They work based on the brain food of theirs that's CAD, 3D CAD. So if you get that type of a technology going, what really happens for you is anything can be made, as was shared before. But you know, about 6.5 years ago, I was looking for what was next. Okay, and I went online like everybody does these days. I think we've all become Googleized. And I was saying, well, what's next in printing, or quote printing, which is a loose term for me because I think it hides too many, people don't understand the different processes. And if that's the case, they think they can print anything, and they equivocate printing with paper, which is cheap. Printing in certain technologies has an escalated cost based on the size and time of the machine versus one machine to another. But when we did that, I typed in and I came up with this technology out of Germany originally called DNLS, which was talked about. And when I got my first part sent to me from the company in Germany, it was a company called Concept Laser. They didn't send me this gun, but I got the part in my hand and I was like, excuse my grammar, I can't go that far. Holy. Okay, why? This was a paradigm shift now. Because when we look at 3D, the way we all thought about it before print, it was like, wow. Because the complaint used to be you can't use the material printer. But now all of a sudden, we have parts that can be made in multiple materials, which was already shared, so I won't repeat all those. But shapes that can't necessarily be made, but I just need one, or I need 10, or I need a couple of chocolate chip cookies. I always go there, just taste it. But you alluded to some of the companies. General Electric bought into this industry about 2 years ago to the tune of $100 million. Why? Little company had 15 metal printers. That wasn't why they bought it. They had a technology and they patented a process for laying up the Johnson & Johnson and Johnson stainless steel baby powder so it can make a turbine blade that works. Talked earlier about how GE is buying up capacity, everything, because they figured out they can make a turbine blade in a year and a half to test versus 5 years. And in that industry, that's huge. Very big. I'm not necessarily promoting NRA activities here. We had these for a client of ours. We put 6,000 rounds through them, and they were testing in 6 days. Traditional process for lowers and a handgun, 7 weeks of machining or more. Because of other processes, EDM, cutting and so on. 7 days. Not biblical, the 8th day they shot them. Okay. Implants. In Europe, our FDA is a little different. In Europe, they've already done full jaw replacements on people with the metal. We're doing projects right now with companies in California for dental implants. They're actually trying to get it certified so they can actually redo your bridge and just print it, put the teeth in, and put it right in your mouth. In California, there's another company called Organovo. They're going through their second round of tests, human kidney biocompatible materials. First one lasted 40 hours. So where's all this going? Who knows? But what's coming out of it is this whole technology of 3D printing and 3D data leading into other processes that are more traditional. Anybody here work in castings? Metals? Okay. Castings is a process called loss wax. You make a wax, you burn it off, and out comes a piece of it. Oh, we gotta make a tool to get to there. That's tradition. The tradition of making a tool is a religious right for certain manufacturers. And why has China and Mexico and India developed their capacity? Because they brought the cost of that down to labor insignificant to anything we could ever do in America. Hopefully bring it back some ways. This will in some ways. Okay. So what happened then? Some of the guys got real ingenious. They figured, hey, we can print 3D wax. And we can make one casting in 7 days. So all of a sudden, as you talked about it earlier, they're putting parts out. All right, they'll do the secondary machining. But they didn't make a tool, they tested one. And for those of you who have to machine parts traditionally to get to some metal work, you didn't have to machine it because you would machine it because I can't cast it, it costs too much. Well, these guys invented a process, or formulated a process then, where they print the same shape, it's got the tolerances of the part, they build in shrink factor. I'm not trying to get overly engineering because I'm not. And then you get a part, stainless steel, aluminum, titanium, anything you want. So that whole process helped another industry that in American some industry areas was dying because the castings were all going offshore. You go to a major trade show, and if there's a die-cast vendor or a company with die-cast service, and you look at the booth, no disrespect to anybody here, there's always one Chinese person. And I've been to shows where vendors who I know who will sell die castings, oh man, they got die castings, it's good, they're clients. Can't go there. This is why. Because the Chinaman in the booth, no disrespect to the Chinese, and he's the guy from the factory. Because those technologies, because of cost, are gone. So they're trying to use all these 3D combinations now to bring it back, or to at least elevate their ability to manufacture quicker, to be more competitive. Even if they're going to go offshore, they're going to make their first 330 or 300 in the United States. They're going to market it, they're going to develop it, they're going to blow it up, they're going to drop it from a plane, they're going to mold it. And not everybody is making it outside the country. There's very good development being done in our country and manufacturing being done in our country. But when you look at certain aspects, what I call trinket manufacturing, much of that's gone. It may stay out, it may come back, I don't know. But where we find our businesses is in the high-tech businesses, or anything from inventors to, you name the manufacturing company making a housewares product. They're all using it, or they all have it. Or they're all putting it in their facilities as mini factories. There are companies now that have 15 metal printers in their facilities. Some are on the way to 20. And all they're going to be is a room this big with metal printers. And they're going to have a couple guys playing video games. And then the rest of the guys are really good high-tech jewelry plungers who sharpen them up and polish them. So what you're looking at in the purpose of looking at 3D for all of you is how does it change what we look to do and what we look to manufacture? Whether you're investing in it, whether you're using it for your fabrication, whether you're using it for your tooling. The next step is, who knows? But keep in mind that 3D concept, which isn't something we've all been thought about, thinking about. I can share with you that when I got in this business, I didn't care how anything got made. I just bought it. Most of us don't even think about it. But now when you look at how things get made, and you look at 3D, all of a sudden it's how's the shape made. And what does the 3D mean? The 3D engineering that you get, that you input, is like your Word document. There's a rumor out there that Microsoft is working on a software right now that will go in the pad, that will let Mary and Judy, mom and daughter, make their own wall plates. And it'll be intuitive, like a Word document, that you'll create it, you think you got it right, but it'll do all the wall thicknesses and everything else. And then you go to Kinko's or a facility, and you'll have your parts made, or you'll do it in your kitchen.
Hopefully it works better than Windows 8.
Well, they got 10. But and it just is a real quick path for you. These are other things we do with 3D tooling. For instance, this is something we did for the Navy SEALs, where this was field material. We literally made, any dentists here? Oh, good. Okay. We literally make what are called rubber molds. And we make a 3D master pattern that's printed like this. And we pull a rubber tool off it. And we cast it. They had special type of missions where they allowed me to show it, where they just needed 20. They're not making hard tools yet. They're doing marketing or application right out of rubber molds. So this is a different way of looking at tooling. We made for the TSA, we made over 300 of these biometric readers. These are cast urethane. Again, 3D pattern, 3D tooling in 2 parts, using it to be the master. We're using it to make injection molds, silicone molds, real part materials. But because we have the 3D, you may have a printer that prints either in a plastic or a rubber. So you could do a onesie to check it out. Someday you may do the whole thing. But it lets us escalate the ability to get the parts out on the street. So from our perspective, what 3D and machines and technology you can be able to purchase, use, or whatever your technology application is, are really just a quantum leap in how we look at the hammer and the rock. It takes you another whole path of speed, expedited manufacturing, and the ability to get your products out in front of people much faster than perhaps ever did before. That's about it for us. I hope you all embrace the 3D world, but not because it's some galactic thing. But it'll really change how you look at manufacturing things you do. Thanks very much. We'll leave this up here for you. But I do put you on a magnetron later to make sure they're all.
So we can bring up Dave Sepanik and Charlie and sure.
Yeah. Wait. Oh, you Jack Carter. No, he's gone.
Any questions? You guys want to sit down or relax?
I would have tried it all day. That's okay.
I have a question to start off. So, what are the hurdles to get from a onesie type of a volume to a low prototype to a high volume, 100,000, 10,000?
It depends. Really.
Well, again, that's probably not the right fit for this technology. Anything that's in volumes of tens to hundreds to thousands, that's pretty much the sweet spot. But what you would be able to do is produce the prototype quickly without having those 3 iterative tooling processes and you'd be able to quickly get it into a hardened tool. And most likely you're going to take it offshore, as most people do, but not necessarily. Things are onboarding here and whatnot. But it's that fine cutoff, Bill, that you have to figure out in your business model.
But if you project out 5, 10, 15 years, it may be that the volume is a no-brainer.
And it can be. And again, I pointed out the clip process. It's 25 to 100 times faster than the traditional plastic processes. So again, commercialization's coming in, and you're right. You may be able to produce 10,000, 100,000 parts in the coming years. Right now, it's just not commercially viable.
We've always looked at it from like a vector approach. When you pick the 3D print, you might look at a 1 to 10, although there are people using it for production now, depending on the material, part, and application. Then you look at whether you do, if you're in plastics, you did one type of tool and you get to that next plane, or you even move from molding. With the expedited abilities because of 3D CAD machine, you're able to get into those bridge tools and then follow your parts through the process. But it really, you almost have to look at materials and application to decide which process is going to take you to the next step. And then what your time can be. Because what you really look at with a lot of these technologies is time. You can sell price, time, and quality. You can't do all three. In the 3D world, if you're using it as a bridge to get there, you're really looking at time and quality. Because otherwise the price point's a volume thing. And that's, again, as was mentioned, it's another whole level. So you have to get that.
Thank you. Great question.
Yes.
I have a question. You mentioned earlier about mixed materials. How often does that happen, and how easy is to mix different materials that you really
In these particular machines, this machine is called the Polyjet object machine. It was developed in Israel. It goes back about 12 years. No, longer. I was in business then. But anyway, the point was like a dot matrix printer. So it's like ink. And they basically, in their particular technology, they figured out how to do that. There are very few yet machines. There are people talking about being able to blend metal. Somebody brought it up to me the other day. I haven't seen it yet. Doesn't mean it's not out there. Because, for instance, I'm talking in the metal world about machines that have a 10 by 10, a 16 by 16 platform. We know there are R&D machines that have about 4 foot by 4 foot, but nobody knows where they are. We know that they are. But the real trick is when we get to that 16 by 16, or even the big plastic machine formats that are up to 20 by 60 or 20 by 20, 30 usually is the big cube. When you get that in the metal world, you'll put a room this big with about 10 machines, and you'll have 2 operators and 7 repair people to clean the parts. That's a fact. That's what's going to happen.
Wow.
And I invite you to actually Google AC Cobra. They actually printed an AC Cobra in a matter of days at the Oak Ridge Institute. It was totally amazing, and it's been on CNBC, and it's been
Very rough show, but
amazing. Yes, but check that out and Google it. You'll be totally impressed at the scalability of 3D printing now.
yes.
Yeah, I was going to say, how do you think the 3D printing industry is going to affect pharmaceuticals? Because I saw today, actually, the FDA has approved 3D printing of medications.
Well, again, what I talked about earlier is material-based. If that's material that people can ingest and dissolve, and they can find other ways to use it as a vehicle, why not? Do I know anything about it personally? No, I haven't done that arena. But, I look at it from the other side, i.e. the body parts. I mean, look, if we can all think about it this way, we're all different ages in here. But let's just all play and pretend that we're all 25 and they scanned us for our medical records. Shoulders, elbows, hips, and knees. The primary replacement bones in your body. They what's called reconstructed surgery. They're taking a piece of mush to what it's supposed to look like and make it fit in your body, and they remove it around the way it works. So when you're 25, we're going to scan you. They're going to put it in your records, and when God forbid you need it, they're going to put it in and shave it to fit, but it basically is your body structure. There are other materials now they're doing where they're building parts and your own body cultures are building over to reconstruct bones. So I don't think we've seen even the beginning of the curve here. What I think we're seeing is the mainstreaming of the knowledge of the technology so that people can grasp it beyond the movie.
Or, my doctor came to me with an investment strategy that is going on where they're actually laser or 3D printing your DNA and creating heart valves, hip replacements with your natural DNA. So it is kind of out there, but it is an evolving technology that could come to roost. You can imagine your mother having to get a hip replacement, and you can just go in and they can digitize it and actually give it to you in a few hours instead of having looking for a donor. That's kind of where this whole technology is moving. That's what makes it exciting.
Hey, how's it being used in the battlefield?
In the battlefield, it's amazing. They're actually now putting 3D printers on battleships and actually printing spare parts right on the battleships because they obviously can't get in, can't fly it in. So it's already there. They're making drone sections of drones, right, and putting them together and deploying those out to the battle theaters throughout the world.
I was at a shop in Gainesville this week where they are printing the drone parts for their units. They're printing them, and those are the application parts. They sent the first unit up to space recently, and when you really think about it, plastic in space weighs the same as metal. So you can send 60 boxes of screws for the next 30 units, or you send up a bag of flour that sits on the shelf when you need it.
I was just up to NASA, one of our customers, and they did a scaled-down version of their rocket engine, and they spun it to 90,000 RPM. I can't even fathom how fast that is, with no failures. So that's really driving the technology, as always, space exploration. So it's really being driven and really optimized in the jet engine and the rocket industry.
Yes.
Andrew?
Do you think that 3D printing will ever come to the cycle times of injection molding in order to pay the costs? That's my first question.
Is there a part B there?
Let's be politically relevant. Let's be politically. This isn't the graduate. I didn't get into plastics. So I think Chairman House saw the movie, and from there on, that was that change in China's economy. But anyway, I think what you have to look at is no. Until the machines are big enough.
It's going to.
And repeatable.
It's happening like
No, I'm making a point. Repeatable enough and big enough that you can basically, I keep using the analogy about cookies. Take the trays, take the trays, take the trays, take the trays. When you can put these machines in an automated process, and the parts you need have to be somewhere between difficult and highly articulated, and the materials can do what you can mold. There are things you mold, materials aren't there yet. So I think, could it be sooner than later? Well, it's going to be certain generic materials. I have clients who print 500 parts on printers, and that works for them. But the same person who I saw this week who's making these parts for the PLA product said to me, I need a faster machine because I'm making them for production, and this just won't cut it.
What about mold cavities and cores with mechanic wrap?
We are now in the direct metal laser centering process. We are doing, we can do cores and cavities, but what drives price is time and density of metal on the machine. So if you've got a really thick mold pattern and you're not just doing an insert, it takes forever. Therefore, what we recommend is you cut your cores and cavities and you print your inserts. Because we can do conformal cooling from a molding perspective. That's really the cooling systems inside the inserts and mold. We can do it right in the molds because in the direct metal, you can go down to 10,000 through holes. It won't necessarily be smooth inside, but that doesn't matter because it flows. Okay. Yes. Yes, sir.
On Friday, the Wall Street Journal had an article that was not exactly favorable to the industry.
So did Barron's about a year ago.
Well, they seem to think that it was like hitting a wall that may change in a couple of years with HP. And the question I have, which is sort of related, is there like a Moore's Law, do you think, with 3D printing? You know Moore's Law about computer speed, it doubles every...
Yeah.
Is there some...
Look, I've been around 3D processes from a printing point of view, if you want to call it. And I always find the words printing in the 3D fabrication world a little bit of a shaky thing. Well, not even, because I think they've made, again, I made the analogy earlier, printing means inexpensive. And therefore, printing in certain machine technologies, while very, very strong for your R&D in-house and very cost competitive for your developing product, as they're showing you here. If I look at some of the other material applications, the part that I thought was going to be very inexpensive on the 3D printer was actually more expensive than on the big machines. Not because they were faster, just the materials were different and how it had to be made. So I think when you look at it, I don't know that speed's going to make the difference. Okay, I think it's just going to be whether people embrace using it and whether the materials are there that people feel are usable enough for them to jump into.
Isn't that like a chicken or the egg kind of?
Well, but that, doesn't every process have that? Look, I've been in this 20 years, and for the first time, everybody's talks about it. And I don't make that makes me some wizard. It's just, when I saw metal, I said, whoa. And it was almost like I said, plastic, okay. But the metal is going through a process right now of acceptance because mentally it's usable. Okay, so when you talk about the aviation companies, the military companies, the gun companies, the implant companies, those are guys where time to market in new products is counted in a year or less. R&D can take years on certain applications, but a year or less can mean millions of dollars in business. So I think it's more about which technology people are going to embrace first. I think if a company like Microsoft comes out with a software that everybody in this room could use, I don't need to put the engineers out of business, that all of a sudden everybody's going to be able to make what they want and just have it made somewhere. And there are little shops all over the country, maker shops now. So.
And HP is actually entering to the market to commercialize it. So look out, the giants coming to the plate, and it could differentiate the whole market.
Well, I saw their machine at the AMO show. It's not so different from everybody else. It's just remember what HP's life is all about.
Charlie, what's your guys' take on that, though, in terms of both from the competitive landscape in that space within HP or some of the other OEMs in more of the 2D world, as well as just from an innovation standpoint? You have some of these companies that are 200 million, 500 million, 1 billion, as opposed to an HP that's 100 billion.
What is HP's primary business?
1939.
What is HP's primary business? Selling it.
They're the global leader in imaging and printing.
No, they're selling heroin. You need their ink, and you buy tons of it. And their machines they run faster and faster, suck more and more ink, and you're addicted to buy another cartridge. And I will give her credit. Part of what Ms. Fiorina was promoting was get into this 3D world because people will buy it. Will buy it. It's print the ink. That's what you.
They'll buy the consumables.
I'm sorry.
That's right. Yeah, consumables.
It was the consumables.
Right, but I'm just saying, okay, whether it's HP or not, I'm just curious. And
So-
your guys' take as to, I feel like that's kind of a negative spin on it. I'm saying if you have a company that had been around since 1939 and has the kind of R&D and resources and kind of global pool of talent, what do you think that would do, A, to the competitive landscape, but I think more importantly in terms of the, driving innovation and force, they announced they're getting into the industry, and as is par, my last company was an elite partner with HP, so I know they say something and it'll be out next quarter, and now it went from, I think, Q1 2016, now we're pushed through 2017, but just wanted to understand your guys' take on, if they announce they're getting in, I think the Stratasys, the 3D Systems, the EnvisionTechs of the world are probably scrambling to say, what are we going to do to innovate in the time we have between now and when they enter? And just your guys' take on that, positive, negative? You think it'll?
I think they're going to, commercialize and make it more affordable in the plastics industry, but I'm not too sure they can step into the metal industry. It's a whole different animal, and it's highly specialized. So I would be surprised if they can actually jump in and make it commercially available to actually start printing metal products. I don't know, Charlie.
And my take, long term, is in the home. And my take on HP long term is they may try to evolve by getting the engineers familiar with the technology. The engineers then take it home from a usage point of view, and then that fits into their model. There are over 700 different printers out there now. In the world.
Desktops.
In the desktop, small printer world, and most people don't see them. But there's a ton of them all being ripped off from made in that other country. And the point is that when you look at it, now that you've got open source in one technology with PLAs, what's going to become an open source in the next technology? I think the only thing that stops this whole thing is the ability of every man and / woman, so it's not a sex thing. It's every man to be able to say, I want it, I see it, I want to make it, Google-ized, so to speak, and they can. When that software becomes available, then the leap happens for everybody to have a machine or a technology. So when, that's just what I say.
Other questions out there?
Like for a fellow person that has like order design, do you have a special software or something that you need, whether that 3D, AutoCAD maybe, to be able to print that?
There are online softwares. Google has a Google Sketch. But sometimes those very rudimentary 3D databases are tough to work with to get the kind of accuracy. But there are there's Google Sketch, there's a couple of other ones. There are regular traditional 3D database software that are very expensive. So you have to find one of those graphic.
Easy to translate it from I'm a designer, I just come out with these cool projects, how can I print it? Is it just to translate it, or it has to go with
The data conversion software, they can take a 2D piece and convert it. Literally, you have to get somebody who's got the skill set or simple software that they can mentally just figure out what they're doing and create the database. Then you can, I mean, UPS, we talked about what's next. UPS is starting a service that if you bring your parts to UPS, they're having them made and shipped back to you.
What do they use?
Some service company you got together with. Who knows? But all it is people giving people access. I mean, that's really what it's all about now. It's access to a technology that can change how you fundamentally make things. It's just, that's where it's going.
There's a cost model, and cost model and cycle time. Once you reach that time, you're going to get all kinds of that.
Amazon's very, very interested in getting into this space. So that could be, again, build to order, real time, throw it on a drone, could be in your house in hours. It's that far out.
Anything else?
Oh, I have some.
Yes.
So the only limitation, because we're in the same thing, just like you guys, we see it from like the front line, and we're here right now. Like this is like the evolution has already begun, and like we're able to get into manufacturing immediately right from it. It's just depending on the materials, what you're using, like that's what's going to really make the difference. But remember,
and it's always been that way.
And it's always been that way. But that's with everything. It's like remember AOL. It was like
I didn't go to work for them.
So that's how it is. So the only limitation that there is, and I do want to say this, there's only one, and it's the design team. Can they engineer it? Like, is SolidWorks powerful enough to make what you need to make? But here's the real thing: is the person that's controlling SolidWorks able to make what you want to make? And that's really what it comes down to. And that's the truth. It's like the design is like the number one thing.
The CAD is the access key.
Exactly. If you can design it, you can create it. Whatever it is, you can make it happen. Guaranteed. So it's like, it's just, you gotta find the right, to make it, you just gotta.
And you just defined our business model.
And that's it. But yeah, that's we're saying we're here.
The talent.
They have the technology, it's here.
That's right.
Any other questions? Really, thank you for letting us chat with you.
I'm Bill Conda from Becoming 3D, your host tonight. I'm the director of sales here. I work very closely with Grant and our partners here at Cam Specialties, as well as 3Access. You all have a brochure at your desk, and it's talking about, the future is faster, smarter, greener. And that's really what we're talking about with this technology, right? And it's really not about, like I think, Charlie was pretty clear about, it's not the future as in, the future. The future's now, right? I mean, this stuff is happening today. I think a lot of us think about, 3D printing as something that's, state of the art, coming, it's great, it's cool. It's been around since 1983. I think a lot of us don't really understand it. And Dave's presentation went into a lot of great things around the benefits of 3D printing, and I don't know, you really need to go through them all again. But it's the customization. It's the ability from a manufacturing perspective to be able to customize, right? No longer do we have to worry about mass production. What's the cost associated with manufacturing something, right? It's the complexity and innovation, and I like this innovation thing. It's like, we take the handcuffs off of designers. We take the handcuffs off those R&D people. They can design things because the capability of 3D printing goes much further than what you can do in traditional manufacturing. A lot of people grab this part off the table over there and were asking me about it, and they said, what is it? And I have no idea what it is. But the thing is that if you look at this,
You didn't make something up, right?
What it is people don't really know how much actually went into creating that simple piece that you see right there.
The point here is that
the
point here is that this was 3D printed. This could not have been developed in traditional manufacturing. It just isn't possible. So if a designer, if R&D, if they needed something like this in the past, they couldn't do it, right? There's been articles and videos and all out there about these jet engines and all these other kind of things. There's an engineer at GE. They had a real issue with some of these parts fitting together correctly, so that the fuel engine, the jet fuels didn't leak in these different fittings. They were having an issue with it. So an engineer came up with a way of designing it in one piece. And I think it was something, I don't remember the numbers, April, keep me honest, and it's 16 pieces, 18 different welds, whatever it might have been. He was able to design it so it could be one piece from end to end. And it was all 3D printed.
40% lighter.
40% lighter. So now we start to get into things like the environmental friendly. We talked about it's greener, right? They're going to be able to save fuel by operating their jets with these kind of parts. Okay, but even when you think about being greener, it's whether I'm even making this octopus. Subtractive manufacturing means I had to start with a block of plastic, and I had to carve away all the stuff I didn't want to be able to leave the octopus. Think about the amount of waste that's involved in doing that. With 3D printing, there is no waste. There was absolutely zero waste to print this little octopus.
Or the reverse, if you make the mold to make that.
Or make the mold, right, exactly. So, so you think about some of these tools. This was brought up several times, right? But, you can talk to, traditional manufacturing, and a lot of their cost goes into manufacturing or making the tools to be able to manufacture the parts. We start to now get into the ability that since we can print the parts, we start to get into a toolless environment. Again, huge cost savings for manufacturers to be able to bring into this space. And this one here, and I know China was brought up in a couple of times. I've read some articles where the Chinese economy is fearful of what 3D printing can potentially do to them. If we stop sending our prototyping manufacturing to China and we start doing it locally because we're giving companies the capability to prototype locally, we can seriously impact the economy in China. And oh, by the way, positively impact the economy in America. So this is a technology that just has tremendous amounts of implication. But what are the things we found around this industry? Grant and I are pretty new to this, so we went out and we actually talked to companies. And one of the things we found is there's definitely some challenges. Technology is progressing, the materials are progressing, a lot of things are happening. But you know something? Unlike your photocopier, they don't understand the service model. Right? Your photocopier breaks in your office. What do? You call some 800 number, you talk to some tech support guy, they send a repair guy out the next day, and by 3 o'clock the thing's fixed, right? That's not really the case in 3D printing. The 3D printing companies are just not at that model from a service perspective. We found out in an electronics manufacturer, they waited 1.5 weeks to see a service guy. And on some of their legacy older equipment, 4 to 6 weeks before they can get a service tech out there to actually fix it. Consumer products company here locally as well. Right? Sure, they waited, they got a service tech to come out, they flew out from Michigan, and they had to pay all the expenses for that technician to fly down from Michigan to actually fix the printer. And that, again, took weeks to arrange for that to happen. And down here, you can see, this company here, they run their printer 24 hours a day. Right? They just have so much demand for their 3D printers, it's running 24 hours a day. So if there's any downtime, look at the impact that downtime has on their business. Right? So guess what? Becoming 3D, we're going to fix that. We're going to fix some of those things. First of all, we're offering best-in-class brands. I'm just going to get into that in 1 second. But we're not sitting here trying to say, this is what I do, this is what I sell, so I'm going to find a way to make it work for you. No, what I want to do is I want to go out and find out what are some of your challenges. What are some of the things that we can help you with? And through some of our partners, like Charlie and David, that we can find the right solutions to meet the needs and the different requirements that you have. That's what we're here to do. And we're not tied to one particular brand. What we're here is to represent the best-in-class level of 3D printing. We're a full-service provider. Right? Through some of our partners, and some of them are actually in the room right now, we can provide you nationwide service for your 3D printers. So unlike having to wait 3.5 weeks to have a technician come out, we have the network of service people that can come out and fix and repair that printer and get you productive again. 3D printers are great, and they better work, right? And they're local, right? We're not going to be putting people on planes to go out and fix your stuff or salespeople. We've got a couple of salespeople. We've got April and Marty back here, both becoming 3D. We've got Matt over there in marketing. We have local resources for you to work with. both from a sales, from a service. We have Cody in the back is also becoming 3D to go out and help you install, help train your users how to use them, to come out and not just fix your printers and everything, how about preventative maintenance? How about we go out there and actually lubricate some of the stuff before they actually break? You know, we've got programs to be able to do that. And that is something that is really industry setting because our competitors aren't doing it. We also offer some flexible financing options. We understand that people have budget requirements. We're going to provide you flexible financing programs that whatever you're purchasing, whatever your budgetary requirements are, we're going to find ways to meet them. I had a meeting with a customer this afternoon that had certain requirements from a capital budget perspective. We're able to create a financial package that's going to meet those requirements. And I talked about product portfolio. 3D Systems is number 2 in the industry. In fact, number 1 in the industry for many years until Stratasys just keeps buying up all these itty-bitty companies. But 3D Systems, we're a leader in the industry. You know, Dave talked about the different technologies around 3D printing and how they're applied. These guys offer it all. We have a portfolio of 3D Systems that go from, you know, the little desktop, you know, filament machines like you saw running downstairs printing beers, all the way through the direct metal print. They have multi-color, multi-jet, multi-materials, all in the same print. They have print envelopes to go from the little itty-bitty detailed custom rings to the very large, you know, 18-inch part. So we're representing some of the best in the industry. EnvisionTech, this is an EnvisionTech part, right? And some of the other ones over there you'll see where you don't actually see the lines in the print. It's extremely high quality. A great portfolio. And Airwolf 3D is in that FDM extrusion, you know, kind of same place, but it's a commercial ready. It's commercial ready. It's large building envelope. It's multi-materials. It's printing in carbon fiber. It's printing nylon. You know, there's a lot of different things. So great stuff. And then of course we've got some of those value prints. You want to buy one to bring home and play around? We got some of that stuff too. But and really there was a study that went out recently. Kind of leads into this one down at the bottom is that in these large corporations, they've got these big $1 million machines, and the engineers love them. But they're being used so much that the engineer has to sit there and wait in line. And the big move in it, and the big trend in this industry is the engineers want to have that printer on their desk, right? They want to just have that little, you know, low spot Robo 3D sitting on their desk. They can do their prototyping and playing around, and then when they're really ready to get serious, they'll send it off to the good printers, right? So there's a whole trend even that, you know, even down here in this low-end printer, there's a whole trend of these companies that, you know, you sit there and you look at a large manufacturing company, and they may buy a couple $1 million machines, but what they really need is about $100,000, $3,000 machines, right? Thanks for attending. You know, this was excellent attendance. I hope you all enjoyed the networking event tonight. I hope you got a lot out of it. I know me sitting in the back, every time I hear these guys speak, I learn something, and I hope you learned something tonight as well. We have an offer for you. If you're looking for a desktop printer, anybody that buys one in the next couple of months, we'll give you 4 free spools of filament to go along with it. And if you're looking at a commercial grade one, because you're here tonight, we're going to give you an extra 10% off. Also, over here, as you leave, we have a whole box of these little.
Grab it
off the bus.
The salespeople sitting there going, "Oh, crap."
Don't take it, we want them.
But you know, we have a whole box of these little octopus. On the way out, if you'd like to bring one home, you'd like to just have a sample, you want to go home and show somebody what can actually be created in a 3D printer, by all means, grab one out of the box.
Put a fishing weight on it, put your fish tank in it.
Great bath toys.
If you'd like to see our presentation, please visit us at www.campspecialties.com. It's available for your presentation.
As you can see, we did record it today, so
We'll be putting out another one as well.
putting out a link.
Anybody who wants a card from us, we can get it to everything on our website.
We would like to recycle as well, so if you don't mind with the lanyards, if you want to throw them on the table on the way out, that way for future events we can reuse them. But thanks again so
You
much.
can take your name out of the
You
inside.
guys enjoyed it. Picture.
Thank you very much.
And then some of the parts here, these are made from the SLA process, and you can tell by feel how extremely well made they are. you don't feel the striations you do in another part like this, you can feel the striations. There's a difference there. This metal amazing part. These little gears. Lovers out equivalent to a press.